Thank you for watching our video demonstration of the dependent samples t-test. The dependent samples t-test, as we know, can be really helpful in understanding difference or change between two sets of scores. And importantly, the dependent samples t-test is analyzing the difference or change between two sets of scores. So each participant will have two scores on one dependent variable. It can help us answer different questions like whether our intervention, treatment, or whatever we've done in our research study was effective. Like if we were looking at a medication to reduce anxiety or a new teaching method, whether or not it improves test scores. These are things that the dependent samples test, t-test helps us answer. So in our example here, we're going to be going step by step to run our dependent samples t-test to determine whether a meditation intervention helped change well-being. So in our data set, we're going to be using a pre-well-being and a post-well-being. So each participant has two well-being. One occurred before the intervention and one occurred after the intervention. Importantly, we need to make sure that the measure type for each variable is set to continuous. So when I double click on the header of the column header for pre-well-being, I see that it's set to continuous. That's indicated by this icon. Same thing for our post-well-being. We want to make sure the measure type is continuous. We see that little icon. Because if we don't have it set to the right measure type, we won't be able to run the dependent samples t-test, and we'll look at that in just a moment. So now that we know the data is set up for the dependent samples t-test, where do we go? We need to go to the menu. We'll select t-test. We're going to select paired samples t-test. That's what Jamovi calls it. Same process, same test. So we're going to select that. And then we see something occur in our results area. We need to tell Jamovi what to do. Now, this is a really important step in the dependent samples t-test for Jamovi is the order matters. So we're interested in whether or not our intervention is effective. And so that means that we need to enter in the variables into the paired variable box in this order, post and pre, because we're interested in whether or not the intervention was effective. We really are looking at the difference between the pre and post, but it feels weird that we put it in that way, but we're really interested in what is the difference after the intervention. So the order is post and then pre. Once we've entered in our variables into the paired variable box, we see that we have post and pre, and then here we have our student's T, or what we understand as the T observed. This is our test statistic. Then we have our degrees of freedom. And then lastly, we have our p-value. So our criteria is that any p-value less than 0.05 is considered statistically significant. In this case, our p-value is way less than 0.05. It's less than 0.001. That's really small. So that's good news. We have statistically significant results. So that's just from our initial output. Let's get the other output that we can get from our additional statistics. We can get mean difference when we check that box. What we get is mean difference and standard error difference. Then if we select confidence interval, this is going to give us our confidence interval around the mean difference. This is the confidence interval that we're looking at whether or not 0 is included. 0 is not included in this range of values of 1.89 to 3.10, which is good news because our results are statistically significant. So we wouldn't expect 0 to be in this range of values. So that's the confidence interval around the mean difference. This is the only confidence interval that Jamovi gives us, and that's the only one that we really need for dependent samples t-test as well. Then we're going to select our practical significance or effect size. This is a Cohen's d of 1.17. That's pretty large. We probably wouldn't see that in the real world. This is made up data to illustrate the process, but based on this value, we can evaluate the effect size as being large. So we could say, wow, this is a really effective intervention in changing well-being. The other thing that we can glean from this is that there was an improvement. And I can see this just based on the values, but because they're positive. So when we're looking at our T observed, because it's positive, we know it's an improvement. But if we're thinking to ourselves, how do I know that? We can select descriptives. This is helpful in understanding the difference because we're looking at mean difference between the two sets of scores. So our post-well-being mean is 24.59 and our pre-well-being is 22.09. So that we would indicate that after the intervention, we had higher well-being on average than we did prior to our intervention. So that's how we kind of interpret it. So we get our mean, median, which we don't really use. We would probably use standard deviation if we were reporting the results. The other thing, if we were looking at this and we're like, I still not really sure, we can click on descriptive plots. This helps us understand the differences. So how we would read this is we have on the x-axis our post-well-being and our pre-well-being, and we look at this legend here, the 0 or the little dot here or circle is the mean, and then the median is the square, which we're not really going to use in this context. But when we're looking at the mean of post-well-being, we can see it's higher than pre-well-being. And sometimes that can be helpful in really sort of anchoring our mind on this idea that there was an improvement after the intervention because the post-well-being average well-being was higher than the pre-average well-being. So the intervention was effective. And we could say we would say it had high practical significance because of the Cohen's d being a large effect size. So that's really how we would go about interpreting the output and also how to run a dependent samples t-test, highlighting some key things. The order matters for how we enter in the variables into the paired variable box. And we can see also that the variables have to be set to measure type of continuous. This is the only measure type that Jamovi will run this analysis on. So those are the two key things to take away. Some other things I'm sure are pretty important, but those are the key distinctions for the dependent samples t-test of what we need to know in order to run that analysis. So that's all I have in this video. Hopefully this was helpful. If you have questions, please let me know.